Okay, so let's start. Thank you very much for attending this session. I'll be talking about Azure SQL network secrets. I'll talk about many networking features related to Azure SQL, and we'll see many details about security and performance related to these networking details that we will see today. So this is me. Jem made a good introduction. Thank you very much. I'm a data platform MVP and I work for DTower software, where I provide many consulting services, and you can see my contacts. It will be a pleasure to stay in touch. It will be a pleasure to connect on social media. Feel free to stay in touch and send any questions you would like. Thanks. So let's move ahead. This is the agenda today. We'll talk about each one of these subjects today, so I'll not dig into them now on the agenda. So let's start about allow Azure services. If you are familiar with the provisioning option of Azure SQL, you'll know that there is an option called allow Azure services to connect to the Azure SQL. And what I'm putting here is to never enable this option. You should never enable this option. Sometimes when we are making experiments, when we are making tests, we get, I confess, even myself, I get a bit, let's say, lazy and just enable this option to make things easier. But in production, we should not do that. We should not enable this option. Why? We should not enable the option allow Azure services. Because this option is not only about your services. Many people think, oh, I will allow all my Azure services to connect to this Azure SQL. No, this option is not about your Azure services. This option is about any Azure service from anyone. So if you enable this option, any service running inside Azure would bypass your Azure SQL firewall. It's almost like turning off your firewall. Anyone who put anything running inside Azure would bypass your Azure SQL firewall. This is bad. This is bad. So any Azure service would bypass your firewall. What should you do instead of enabling this option? You should use virtual networks instead of enabling Azure services. If you have a specific IP that you can open a specific IP would be better. But in case you don't have a specific IP that you can open about the services, it would be better to use virtual networks to make the access to Azure SQL. We will see examples about this later during this session. So this is quite important to never enable this option of allowing Azure services. Then let's talk about the two firewalls that Azure SQL has. Yes, a tale of two firewalls. We're talking about two firewalls, not one firewall, two firewalls, because Azure SQL has two firewalls. Many people know one of them and think, okay, Azure SQL has one firewall. No, Azure SQL has two firewalls, not one firewall, two firewalls. And that's the point. That's a secret related to Azure SQL. There are two files in place. And how these firewalls work together? Azure SQL has a database level firewall. Each database in Azure SQL has its own firewall, and we can define firewall rules on the database level. Firewall rules can be defined on the database level. Each database has its own firewall. When a connection arrives to Azure SQL, first the database level firewall is checked. If there is a rule inside the database enabling the access, so the user can connect directly to that database. The database to which he is connecting to and has a rule allowing his connection. So it's a connection specific to one database. If there is no database rule allowing the access, then the server level firewall will be checked. And when the server level firewall is checked, if the IP is allowed, the user will be able to connect. And being able to connect, the user will be able to see all the database. Of course, the firewall is not the only security level on Azure SQL. We also have the authentication protecting our database. The authentication that we use on Azure SQL database is protecting our database, of course. But we need to use correctly these firewalls. If we use these firewalls in a wrong way, we are misusing some of our protection levels. We are relying only on fewer protection levels like the authentication. That's not good. We have multiple protection levels. It's good if we make a good use of them. And what's a good use of these files? A good use of these files is to give the users the minimal permission that they need. If the user needs a permission to only one single database, so open the file for that user inside the database. Not on the server level file, but inside the database that user will have access to. So you should control when you should open the firewall rule inside the database level and when you should open the firewall rule on the server level firewall. Some of you may be a bit confused because you may not have seen this database level firewall before. Why? Because there is no UI for it. There is no user interface for the database level firewall. If you want to enable a permission, enable one client IP on the database level firewall, you need to do it by code, by TSQL code. Calling stored procedure, system stored procedure on the database, while the server level file is on the UI, on the SQL Server in the portal. That's why many people misuse these files. Many people misuse these files and just open the server level file to everyone who needs access, even if the person only needs access to one single database. And this needs to be fixed. This needs to be solved. A different view about that, another view about that. First, we know that the server needs to allow public network access. If the server denies public network access, the workflow to access the Azure SQL is different. It's from a private endpoint. We will talk about this on this session as well. Then, if the server allows public network access, first the virtual network firewall rules will be checked. I will talk then about them later. After the virtual network firewall rules are checked, the database level rules are checked, and the server level firewall rules is the last one which is checked. And you can see here the system table where these firewall rules are kept. Sys database firewall rules or sys firewall rules. So we have two different system tables to keep these firewall rules. The server level firewall has a UI in the portal. That's why many people keep opening the server level firewall when the database level firewall would be better. Let's try. Tests about this. Okay. I have here my SQL Server. Is an Azure SQL. Let me delete these IPs from here, from the file, save. At the moment, I have no IP open in the firewall. And the option to allow Azure services is disabled. The option to allow Azure services is disabled. Then let's connect to this SQL Server from my local machine. First, I'll connect from my local machine. We'll use SSMS. So connect SQL Server. It's this SQL Server. When SSMS first connects to Azure SQL, it gives me the option to open a firewall if I would like so. If I would like so, it gives me the option to create a firewall to my machine. But I need to be the administrator of the Azure SQL in the portal to be able to open this firewall. In this case, from my laptop, I will do so. I will open the firewall, a server level firewall from my laptop. But it's important to not do this automatically, to understand what we are doing when this window appears. When this window appears, we are opening a server firewall and adding this IP to the server level firewall. So by doing this, I have access to the entire server. I can see all 3 databases on this server. And let's get back to the Azure SQL. Let's take a look on the firewall rules. Firewall and virtual networking, refresh. And here you can see my IP, the IP from my client machine, my laptop open on this SQL Server, this Azure SQL Server. Okay. Now, as an example, let's do what I told you to not do. Let's allow Azure services to access this resource and save. I told you to not do that, but as an example, I will enable this for now. So I use one virtual machine. I have one virtual machine on Azure connected to Azure, and I'll make a connection to the SQL Server. So let's try to connect to this SQL Server. That's it. I'm able to connect to the SQL Server from the virtual machine without receiving any complaint about the firewall. Why? Because the option to enable Azure services to access this resource is enabled. And it's just a detail that this virtual machine belongs to me, okay, but it could be a virtual machine belonging to anyone, and the file would be bypassed. The file would be bypassed by any Azure service. You should not enable this option. You should not enable this option. So let's change this option to no. Save again. And let's take a look on our connection. I will close this connection, disconnect, and try to connect again. And now I receive a complaint about the firewall. And SSMS gives me the option to open a firewall rule. SSMS gives me an option to open a firewall rule. Just a moment. Let me take a look on the chat. It seems. Yes. First, is this option turned off by default? Yes, this option is turned off by default. But it's easy to fall in temptation to turn this option on depending on the service that you are using. It's easy to fall on this temptation. Don't go for it. Don't go for it. Take care about this temptation. Olev is asking, can it be created a policy to allow all Azure services setting to be turned on? It's difficult. It's difficult. A policy can be created for many purposes, but this option is difficult to track on the object structure. It's difficult to track. I'm not completely sure that an option to prevent this is a policy to prevent this is possible. But you can follow up with this about this question with me, and I can double check it for you. But it's not an easy policy to create. I can already tell you. And what I was talking about, I was talking about don't use this screen in, let's say, in automatic mode. Don't go in automatic mode and start creating firewall rules. Take care about what this screen means. This screen means that I would be creating a firewall rule on the server level. Do I want to create a server level firewall rule? Or maybe for this machine, on this specific situation, I only need a database level firewall rule. If everything I need is a database level firewall rule, I can create a database level firewall rule instead of a server level firewall rule. I can use DB1 and create a database level firewall rule. Let's do this. So, you see, to set one firewall rule. Here, SP set database firewall rule will include our rule. I need to know exactly the IP I'll be using for this firewall rule. Sorry, wrong virtual machine. So let's the IP here. It tells the IP to me here. 52.188.203 and 52.203 and 173. This is the IP that I need to open, and I will open it in a single database and not for all the databases. So I'll create this file rule. File rule is created inside the database. And I can query the file rules. Let's take a look on this database file rules, and I see this rule created inside the database. Okay, so this rule is inside the database. Then I can get back here. Which database? DB1. In this case, I need to make a connection directly to the database. If I don't specify the database I'm connecting to, it will check database level file rules. It will only check database level file rules if I connect to one specific database. So DB1. I need to make a connection directly to DB1 using my login. My login is a server administrator, has access to the entire server, but I'll connect only to DB1 and see the firewall is open for DB1. I can connect to DB1. Not a problem. So I have access to DB1 to make a connection to DB1. But if I try to make the connection without specifying the database, let's not specify the database and try to connect, I get the firewall complaint. So the firewall is blocking the connection from this machine to connect to server level. The machine is only allowed to connect to one database. So in this way, we are making a better use of the two firewalls in Azure SQL. In this way, we are using the two firewalls in a better way. Okay. We saw an example about the firewalls. Okay, now let's talk about Azure Id Authentication. How do we enable Azure Id on our Azure SQL? The method to enable Azure Id Authentication is to have an administrator created from the Azure Id. I need to define the administrator of the server as an Azure AD user. After defining this, I can choose to enable only Azure AD Authentication or to allow both kinds of authentication. If I check this box, I will be enabling only Azure AD Authentication, making my server more secure. Otherwise, I can leave both authentication enabled in case I need that. In case I need to make both authentications enabled. So defining a group instead of a user is not a good idea to put a user on this position. The good idea is to put a group on this kind of position. And optionally, we can use AD-only authentication. And we can enforce these configurations using policies. I don't have the link here at the moment, but I on Simple Talk blog post you can check on Simple Talk website about how to write these policies to enforce the check and enforce the AD-only authentication. I wrote the policies there for this purpose. So you can check and check how to enforce these if you'd like using policies. Let's see how we can do this in relation to Azure AD Authentication. So let me open another window, the portal in another window. Okay, so I'll go to Azure Active Directory. Azure Active Directory, groups, new group. Let's create a group called Security Group, Secure Admin. And I'll put myself as a member of this group. In fact, it's an account that I have, Dennis AZ900, outlook.com. Create. Okay. So now that we have the group defined, we can add this group as the admin of our Azure SQL. SQL admins. So I add the group as the admin of my Azure SQL. So I can save. Disconnect. Connect again. And now I use Azure Active Directory Universal with MFA. So now my authentication to Azure SQL is my Azure account. I can use my Azure account to authenticate to Azure SQL. That's interesting. So using this feature, I enable the Azure AD authentication. I will not enable Azure AD only authentication, but you got the idea. If I enable this option, I would not be able to connect with regular SQL Server users, only with Active Directory users. And this would make my environment. Many of you would ask, what if I'm connecting from an application, a Logic app, or an Azure function? This application should have a managed identity. Having a managed identity, you can give access to them to your Azure SQL, and still supporting only Azure AD authentication. So the idea is that the applications that are connecting to Azure SQL would use identity to connect to Azure SQL, making the entire environment safer. Okay, let's move ahead. Secondary replicas and connection. What's this? This is about how they have managed behind the scenes on the Azure SQL. There are two different methods. The general purpose tier on Azure SQL manages high availability in one way. The business critical tier in Azure SQL manages high availability in a different way. How this is managed? It's this image that both of them, either general purpose, business critical, either of them use a gateway ring, a control ring. What this means? All the connections arriving to our Azure SQL, all the connections to our Azure SQL arrive to this gateway, the gateway ring, the control ring. And then these connections are, let's say, forwarded to the server itself. We'll talk more about this later, but it's interesting to know that these gateways are here. The general purpose tier has high availability using the storage. The storage is shell redundant. The storage is kept in a shell redundant way, and there is a replica of the storage. So if Azure SQL goes down, another, let's say, VM is put up and running with our Azure SQL using the replica of the storage. This is how the general purpose handles high availability. The business critical layer, on the other hand, uses an always on availability group and has failover secondary replicas for our primary Azure SQL. So there are failover secondary replicas for our Azure SQL, and we don't see these replicas immediately. We don't have a view of these replicas, but they are there. They are there. So how can we connect to these secondary replicas? Could we connect to these secondary replicas? This is a new feature that was recently included on Azure SQL to make these replicas readable, allow these replicas to be readable. So you can redirect reading connections, for example, connections that are used for reporting purpose, for example, to the replica. And in this way, you can make a balance of your workload. If you know that some connection will only read data, you can redirect that connection to the replica, which is responsible for the high availability, but only allows reading. My database, DB3, is on the business critical tier. This DB3 has this kind of replica. So let me connect to it.
Dennis?
Yes?
The sound is chopping a little bit from time to time, so maybe it would be more stable if you turn off the webcam.
Oh, the sound is failing.
Not constantly, but from time to time, it's lagging a little bit.
Okay, sorry. Let me check. Okay.
Yeah, I'll let you
I
know if it's a problem, but just try to have the webcam off and we'll see if it gets better.
Okay, thank you very much.
Yeah.
So I'll be connecting to the DB3 database, DB3, and I want to connect to the secondary replica. I want to make a connection to the secondary replica. How do I manage this? We can use the connection parameters, and on connection parameters, I can specify application intent, read only. So here I can specify application intent read only. This is a feature that is available for our zone, and it works with Azure SQL when the secondary replica read available. So I can make the connection. It's very difficult to notice that we are on a secondary replica. The only clue that we have that I'm really on a secondary replica is to check a database property that will tell us that this database is not updatable. I check the database property that will tell us this database is read-only, is not updatable. So due to that, I know that I'm connecting to the secondary replica and not to the primary replica. I'm connected to the secondary replica. So by adjusting the connection string in this way, by using the application intent read-only on the connection string of your application, you can redirect applications to connect to the secondary replica if you are using a business critical layer. In this case, you can break down your workloads between the primary replica and the secondary replica, and your report workloads can be working on the secondary replica. And that's a good idea to break down your workloads. Okay, moving ahead. Redirect versus proxy versus default. This is a configuration that we have on the connection configuration of SQL Server. What this means? This is completely related to the gateways that we just talked about. Here we see the default option, the proxy option, and the redirect option. What this means? This is related to the gateway, the connectivity models. When the proxy model is used, what happens? A connection goes to the gateway, and the gateway becomes a middleman for this connection. The client machine, the client application never has a direct contact to the server itself, which hosts the Azure SQL. So the gateway is always the middleman for this connection. But if the redirect policy is in place, if the redirect policy is in place, then the connection goes to the gateway and the gateway redirects the connection to the Azure SQL Server. So in this case, the client application goes directly talking to the Azure SQL Server. What the benefits and the problems of each of these connections? Well, the proxy connection is safer because the client application never goes directly to the Azure SQL Server. So it's safer. But there is a middleman, and having a middleman, it is lower. So it's safer, but it's lower. While the redirect option is faster, but not so safe, because the client application will have contact with the direct Azure SQL Server, the server where Azure SQL is. Okay, so, and the default option, there is a default option. What's the default option? The default option is to use both at the same time. And the Azure SQL Server decides when to use proxy and when to use the redirect. Due to that, the default option usually is the best one. Let Azure SQL decide when to use what connection, and it's up to you to ensure that your applications will be using redirect. How is that? Simple. If the connectivity comes from outside Azure, using the default option, the Azure SQL will decide to use the proxy option because the connectivity comes from outside Azure, so it's not so safe. But if the connectivity comes from inside Azure, from an application which is inside Azure, then the Azure SQL will decide to use the redirect option. Azure SQL considers a connection coming from inside Azure as being safer than a connection coming from outside Azure. Okay, let's try this. Let's make some tests with this option. Let me go to my virtual machine. Okay. Before connecting, let's change the connectivity model. Let's test both connectivity models. So here in the same window where I define the firewall rules, I can define the connectivity models as proxy or redirect. First, I'll try the proxy one, the proxy connectivity model. And my connection here is made directly to DB1, so I'm trying the proxy connection model directly to DB1. Okay, select staff from sales LT customer. Let me repeat this 20 times to give some volume to this call. And I will use Notepad to take some notes here about the results. And to check the result, sorry, it was not this. To check the result, I will enable the client statistics. Enable client statistics. So I will run this. Client statistics enable, and the result is 78. Let's take a note about this. Okay. Let me close this SMS to be sure I'm completely closing the connection. And then I'll change the connection policy to redirect and save. Okay. So I changed the connection policy to redirect, save, and I open again SMS. These are milliseconds. Of course, you need to mind that this query is very small, and with bigger queries, a difference on the time would be bigger. Now the server is already configured to use the redirect mode. So DB1, let's execute this again. And let's include client statistics. Execute client statistics 62. The difference was not so big as I would like to highlight that. There is one point about this difference as well. Let me just take a note about that. So redirect went to 62 milliseconds, and the proxy went to 78 milliseconds. There is a difference on the wait time. It's not so big, but it's a difference. So your applications can be faster if they use the redirect mode. That's the point. That's the point that I'm highlighting here. But another difference that affects the result as well is the fact that I'm connecting only to the P1. I confess I made this test before the presentation just to be sure about the result. And when I'm connecting to the entire server and not only to a single database, the difference between proxy and redirect is even bigger. I got a difference for this query. I got a difference of 100 milliseconds of difference, and this query is very small. Imagine this difference with bigger queries. The difference will be way bigger. That's the point. So this difference can increase according to query increase because the gateway will be a middleman if you choose the proxy option. Another point related to proxy or redirect is the fact that the redirect requires a specific connection permissions, specific ports and connections made directly from the application to the server, to the Azure SQL server. If in the middle between the client and the server, there is someone blocking any of the ports that are needed, the connection reverts automatically to a proxy connection. So the connection gets back automatically to a proxy connection instead of using the redirect connection. Okay, so we talked about the redirecting proxy in relation to the gateways and how the redirect is better for your application. If you can ensure that your applications will be running from inside Azure, and in this way using redirect, this is the better solution. This will ensure a better performance for your applications. Now let's talk about service link. Let me raise a problem first. Let me raise a problem to illustrate how self-link solves this problem. Let me close this connection. And let's imagine that I really would like to make a server level connection, not a connection only to the DB1. The DB1 I already have approval of the firewall. Let's imagine that I really want to make a connection on a server level basis. I want to make a server level connection. How can I do that? Well, I connect without specifying the database. Let me be sure the password is correct. And it gives me this this message complaining about the firewall. One more time, I'm repeating this. Don't work automatically on this screen. Don't start automatically opening firewalls on this screen. Analyze this screen. Check why this screen is appearing and if it really should appear here, because there is a problem. My Azure SQL is inside Azure. My Azure SQL is inside Azure. My virtual machine is inside Azure as well. Both my Azure SQL and my virtual machine are both inside Azure. They are both inside Azure. If they are both inside Azure, why my virtual machine is trying to access Azure SQL using a public IP? Take a look. 52.188.203.173. This is a public IP. Why my virtual machine is trying to access Azure SQL using a public IP? And some of you may ask, what's wrong with that? What's the problem of using a public IP? The problem is that if my virtual machine is using a public IP, this means that the traffic between the virtual machine and the Azure SQL may be passing through internet. The exchange of package, the connection and the exchange of data between the virtual machine and the Azure SQL may be crossing public internet. And you don't want this to happen. If your virtual machine is inside Azure and your Azure SQL, of course, is inside Azure, why would you like to connect to public internet and not to ensure your connection is completely private, completely inside Azure? That's the point. That's the point. We would like to ensure that our connection is completely inside Azure. How can we ensure that? Well, the firewall has another option that we haven't talked about yet, the virtual networks. I can add a virtual network, an Azure virtual network to the firewall. I can create an Azure virtual network here on the firewall rules. And it's even suggesting me to add my VMRG VNet to the firewall. Okay, I ignore missing SQL service in the box. At this moment, I'll check this box to make a demonstration. So I will add my virtual network to the firewall. Meanwhile, while adding that virtual network, I will open the virtual network here. Okay, and we can see that we have no service endpoint inside the virtual network. There is no service endpoint here inside this virtual network. And the virtual network is included inside the Azure firewall. Okay, now let's try to make the connection again. Let's try to connect again. Database engine. Oh, sorry. It's connected to database one. Database one, I have firewall permission for that. Database engine. I want to connect to the server level, the full database. And I get the firewall complaint again. This means my connection is still going through public internet. My connection is still going through public internet, even after I included my virtual network there. This means including the virtual network here is not enough. Including the virtual network here is not enough. So I'm deleting the virtual network from here. And now that I deleted the virtual network from here, I will include again, not checking this checkbox. What this means? This means that when I'm creating this virtual network inside the Azure SQL firewall, it's also checking that my virtual network has no service endpoint. And there is a need to have a service endpoint for Azure SQL inside the virtual network, enable. The first click that I did on the enable, create the service endpoint here, I can already see a Microsoft SQL service endpoint. What this service endpoint does? This service endpoint creates a private route between my virtual network and the Azure SQL Server to ensure that the connection will work privately and not through a public IP. So after creating the service endpoint, I click OK, and my virtual network will be included in the firewall. That's it. So the virtual network is included in the firewall. Okay. Now I will go to my Azure SQL, my virtual machine again, and try to connect one more time. Connect. I connected immediately. And now the connection was totally private. First lesson that we get from this is the usage of a self. And this will ensure that the connection from that virtual network to another Azure service will stay private inside the Azure environment and will never cross the public internet space. Will go completely private inside the Azure space. The second lesson that we get from this is to take care with the firewall error message. If the firewall error message appears, you need to understand if you really need to open the firewall or if you have some other configuration missing, like a CERF link missing, and you may need to configure the firewall for the virtual network and not for the IP that is appearing on the error message. That's an important point, a very important point. But to complete the demonstrations, I hope there is no problem if I pass about 5 minutes. To complete the demonstrations, it's important to note that this SaaS endpoint that I just created is still need that this Azure SQL have a public endpoint, a public network, allow public network access. So this SaaS endpoint defines a route from the virtual network to the public network endpoint, the public endpoint of Azure SQL. What if I would like to deny public network access? I want to make this Azure SQL completely private. And this is something good. This is something very good to make this Azure SQL completely private. Let me delete this virtual network. I will not need this virtual network here anymore on the firewall because the firewall will not be used anymore for that. Okay. So now that the SQL Server is completely private, if I want to make access from that virtual network to the Azure SQL, I need to create what is called a private endpoint. I need to create a private endpoint inside that virtual network. The private endpoint is like if I'm inserting my Azure SQL inside that virtual network. So I'll create a private endpoint to that virtual network. Name of the private endpoint, MySQL private endpoint. Okay, region is the region of my virtual network. Let me double check the region for my virtual network. If I'm not mistaken, is east-west. East-west. Then, although I started from the Azure SQL, it still asks me the resource. So SQL Server Malta, target sub-resource SQL Server. Okay. Then the virtual network where I would like to create this private endpoint, this virtual network. And it will create a DNS zone, a private DNS zone, private database windows.net. Okay. review and create. And create. So the private endpoint is being created. Meanwhile, I can prepare another connection from my VM to the server. The full. Just a moment for the private endpoint to be created. Meanwhile, I can make an additional test since it's still being created. I can make an NS lookup for this address and check the answer. Oh, the private endpoint is already in place. It's already pointing to private link. Let's just let it complete the deployment. And the point is, the private endpoint once deployed will allow my virtual machine to make a connection to this Azure SQL, even not allow public connections. It will be denying public connections, but it will allow connection for this virtual network because the Azure SQL is being inserted by the private endpoint inside this virtual network. If I need to manage my Azure SQL, of course I can manage my Azure SQL through the virtual machines, but another option that we also have to manage this Azure SQL is to establish a VPN connection with the company, with your company office. You can establish a VPN connection and in this way manage the Azure SQL through the private endpoint. There are some tweaks about DNS redirection because the private endpoint is based on DNS. So you need to take care about DNS redirection while using the private endpoint and a VPN. But this is the safe option to manage our Azure SQL. We make our Azure SQL completely private. And I would put the question, why do you need your Azure SQL public? Why do you need your Azure SQL to have a public endpoint? Isn't your Azure SQL working behind applications that you are building? Isn't your Azure SQL supporting the applications that you are building? Your applications need to be public, but your Azure don't need to be public. So you can make your Azure SQL completely private and manage it through a private endpoint. So that's the point, and this makes the Azure SQL way safer. Still deploying, sorry about the delay. While it's deploying, let me leave my contacts here. Feel free to get in touch to keep connected. It will be a pleasure to stay connected. Let me check the chat. I think there were some questions here. I would need to review the questions. Eden asked about the allow Azure services and resources to access this server. Yes. If you enable this option, if you set this option to yes, this is just one layer of security, is the layer of the firewall. If you set this option to yes, the firewall layer open. Any Azure service can bypass the firewall, but you have other security levels like the authentication. But the point is to have security managed in multiple layers. The firewall is one layer, the authentication is another layer. It's not a good idea to leave a layer totally open like this. The private endpoint was mentioned, yes, and I'm making an example now. Adam raised an interesting point. Yes, the SaaS endpoint allows you to talk to any Azure SQL on that region. The private endpoint, no, sorry, my bad. The SaaS link allows you to talk to any Azure SQL on that region. The SaaS endpoint is specific by region. The reason of that is exactly what you are mentioning. It's opening a range of IPs, so it opens a range of IPs for one specific region. Thank you, Jonas. Good to know that you like the session, like the content of the session. Erland discovered a technical detail that I have not mentioned, is that this is what makes creating a policy for the allow Azure services to access it. That is what makes creating the policy difficult, because there is no setting internally for this. When you check that checkbox, it adds a firewall rule of 00000, allowing 000, a special firewall rule that is checked in special ways. So the policy can't check for that option, that checkbox. The policy needs to check for one specific firewall rule. This makes very difficult to build this policy. That's what makes difficult to build the policy for the allow Azure services. Thank you that you like it, Adam. So let me double check here. Our private endpoint is already created. And the private endpoint once created the private endpoint object. We have here a private endpoint object. And we have here a private DNS zone. A private DNS zone is created for the private endpoint. A network interface to put the private endpoint inside that virtual network is also created. Once this is created, we can double check the DNS lookup. And we see now it's going directly to private link. So the result of the DNS lookup changed after the private endpoint is in place, and allows me to connect to our Azure SQL, even with the deny public access enable. So we can use the private endpoint to ensure the security of our Azure SQL. Thank you. Good to know that you liked the session. Thank you very much for attending this session. Thank you very much. You have